Hello everyone. In this video, let us see how to obtain the orthographic projection of the given isometric projection drawing. This will be the lecture series on orthographic projections. Each video will contain two different set of drawings. Now, let us see the first question here. Draw the front, top and side view from the left for the following isometric drawing using orthographic projections. Use first angle projection method only. So this is the isometric drawing given. Isometric projection is the one which gives you three-dimension view of any object. That means to say that you can visualize the x-axis, y-axis as well as the z-axis. But when it comes to the case of orthographic projections, we will be having only two dimensions, xy dimension or yz dimension or x and z dimension. So with this isometric projection, we are supposed to convert into orthographic projection. That means to say that we wanted the front view of the geometry, top view and the side view of the geometry. Here you can see clearly indicating this is a reference along the x-axis. That means to say that this is the front view of the object, followed by this is the side view of the object, and this would be the top view of the object. Before going for a solution, let us understand what is the meaning of first angle projection. First angle projection is a condition where the front view and the top view would be in the same vertical line. If it is separated by a reference line, so this would be VP, vertical plane, and the horizontal plane condition. So this is what we call it as the first angle projection. And what is third angle projection? Since top view would be above the reference line and the front view would be below the reference line. Where would be the side view? Very important. The front view and the top view should be in the same vertical line, irrespective of the type of projection, whether it is a first angle projection or the third angle projection. And side view should come in horizontal with the front view. So this will be the side view or this will be the side view. That means to say that depends upon the right side view or left side view. If it is a case of a third angle projection, the side view would come towards this side or side view would come towards this side. So what is the conclusion from both the projections? So front view and the top view should be in the same vertical line, and front view and side view should be in the same horizontal line. Now coming back to the question here, we can see some structure over here. Here there is an object. We are supposed to obtain the top, front and side view of the object. And that means to say that isometric now should be converted into orthographic projection along this as the reference, x as the reference. So as I told, this will be the front view, this is the side view and the top view. So first and the foremost thing is, let us draw the XY line. How to analyze? Just imagine observer is looking from this side. So for the observer, this becomes the right side and this becomes the left side. Just imagine you yourself as the observer. Don't you think this portion is clearly visible for the observer? Later we can see the dimensions. Not to forget, even this part is clearly visible. This also appears to be front. Even this staircase, this vertical height of the staircase is also visible for the observer. So whenever the observer is looking from this end, I repeat, this is the left side and this is the right side. I'm not talking about left side view or right side view, just normal directions, left direction and the right side. Observer can see this 104 mm followed by a vertical height. What is the height here? We can see the height is given towards the other side of the geometry. What is the height? 48 mm followed by this side. There is a sideways, that is 24 mm. Come down to a distance. What is the distance you are supposed to come down? Come down to 16 mm followed by 16 mm and finish this block. This is something like a L-shaped panel. And this block appears to be front. This block appears to be front. Now let us first obtain 104 by 48. So this is the XY line. I will call it as VP by HP, indicating this is first angle projection as clearly mentioned in the question. Now let me go with scale 1:1 scale factor. 104 means I will take 10.4 centimeters in the normal scale. Followed by, what is the height? 48. Yes, this is completed now. 104 by 48. Now, don't you think this thickness is visible? So what is this thickness? Overall thickness is 48. So 16 mm thickness goes with this height. 16 mm thickness goes with this height. So 32 mm over. So left out is even this should be now 16 mm. So simple calculation. So let us mark 16, 1.6 centimeters in my normal scale. So that goes all along this length and rises with a height. What is the height here? So this height towards the right hand side, I need this 24 mm thickness. I am supposed to show 24 mm. I will draw a line for 16 mm and I will draw a vertical line for 24 mm to show the height. So both will intersect at a point and I will highlight, I will darken that particular thickness. Yes, now this L-shaped pattern is obtained, and now this thickness, this 16 mm appears to be front. As I told you, this will be in coordination with these lines. It appears to be in a same straight line. What is the height here? 16 mm. Already I have taken 16. Further I will take 16. Yes, this thickness is visible. Followed by this thickness is visible, already that is shown. So this would be the front view representation. Meanwhile, I will update the dimensions. This completes the front view of the given object. Now let us see the top view. The top view, observer is looking from the top. Now I will make use of a different representation. So I will call this representation. So this is clearly visible. Yes, this line is clearly visible. I repeat, this is the right side and this is the left side. So there is L shape is visible for the top view. And not to forget, so this 24 mm appears to be on the same straight line. This 24 mm appears to be lifted. Means to say that this plane is in line with this plane is in line with this plane. And very important observation, don't you think, what is this dimension I am supposed to take? This is nothing but this dimension, that is nothing but 104. 104 divided by 72. First thing is I should draw a rectangle of 104 by 72. Yes, already 104 is projected in the front view. So what does that mean? The base of the front view is equal to the base of the top view. The first important conclusion. So let us just go for a normal projection. With any convenient distance, I will take the line. What is the height? That is nothing but 72. I will mark 7.2 centimeters in my normal scale. So here is a top view representation, 104 by 72. As I told you, the base in the front view is equal to the base of the top view. Now, what are all the things visible? Now, don't you think this end is visible? So where is this end? This end is towards the right hand side. So this complete platform is visible. So what is this platform? 24. Already 24 mm in the front view, we have drawn the line. Only thing is we are just go for the projection. So this complete straight platform is visible, followed by this platform. What is this platform? This length is not given, but we are supposed to analyze from the other end. So this is given 24 mm, this width is given 24 mm, so 48 mm. So what is remaining here? Don't you think this distance is nothing but 72 minus of 48? Why 72? This side is 72. So 72 minus of 24 plus 24, 48 means remaining should be 24 mm. So 24 mm, let me mark a point 24 mm and I will just draw one reference line. That means to say that I am supposed to divide it into three parts, 24, 24 and 24. Further, I will go with one more 24. Yes, it is divided into three parts. But what are all the things very clearly visible? This L shape is visible. Let us darken this L shape. Followed by this height seems to be increased, this height seems to be increased. Let us construct one line so that the top view is now obtained. So this would be the top view representation. Let us update the dimension. Now let us go for side view. So in order to obtain the side view, I need one more reference line. So I will be drawing one more reference line under the naming x1, y1. So from this intersection point, I will draw 45-degree line. I will draw a line from this end till it touches the 45-degree line. So, draw a line till it touches the 45-degree line. From this intersection point, give a rise. So from the front view, also draw a line so that it intersects the previous line. Since it was the first case, it was the first example, the sheet management was not proper, so I pasted this drawing over here. I will make sure this won't repeat for the next questions. But what is the conclusion here? We have learned that the base of the front view is equal to the base of the top view. Here we are having a proof here. The base of the front view, 104, is nothing but the base of the, or length of the front view is equal to length in the top view. So what is the one more conclusion we are having? The height of the top view, don't you think this 72 mm, if it is projected like this, it goes all along the geometry, and don't you think that becomes the base for the side view? Here itself we are having the confirmation. That is the base of the side view. And what is the one more confirmation from this end? The height of the front view is nothing but the height in the side view. So these three things are extremely important. So what are all the things that is visible in the side view? I will make use of pen over here. I will show some representation, something like this. So these things are visible. So this L shape is visible. Clear? So what is the height? Height is equal to 48 mm. That is, we have obtained from this side, from the front view. And what is the width here? Width is nothing but the 72 mm. That is what we are, that is nothing but the height of the top view. The base is 60 mm. Give a rise of 48 mm. Move towards this distance. What is this distance? This distance already we know it is 24. Drop down by 16, 24, come down by 16, 24, come down by 16. So thereby the drawing is obtained. So before going for that one, let me project from all the end. Yes, if you are looking from the side, now this becomes the left hand side, this becomes the right hand side. So this height is visible, 48 mm height. Let us darken here. So this is the height 48, followed by a width of 24 mm. This width 24 mm we have taken from the top view. So this 24 is visible. Come down to a distance of 16 mm. Further, give a width of 24 mm. We are having 24, something like L-shaped pattern. Followed by drop down by 16 mm. Further followed by 24 mm. And come down by 16 mm. So finish the sketch. What is it we have left out? When the observer is viewing from this end, yes, this portion is now completed. Now, don't you think even this face of the object is visible? This has to be shown here. So where is that portion? That portion is that already we have obtained the projection. Only thing is we are supposed to darken it. Increase the thickness of the line. Increase the thickness of the line here. So this left out portion is nothing but this portion. By this, the front view, top view and side view is completed. Now let us go for the second drawing. The question is same. Draw front, top and side views of the following isometric drawing using orthographic projection. There is an isometric drawing over here, and that means that x-axis, y-axis and z-axis are clearly visible. We are supposed to obtain in 2-dimension view. I wanted front view, top view and side view. So what is the takeaway point from the previous question? Front view and top view should be on the same vertical line. Front view and side view should be on the same horizontal line. What is the major difference between the question number 1 and 2 here is the reference of axis, the reference axis. The previous case, the reference was towards this side. So for the previous question, for me, for the observer, the left hand side of the object was clearly visible. Henceforth, I showed it towards the right hand side. But for this question, for me, right side view of the object is clearly visible. Henceforth, I should draw the side view towards the left hand side. Let me go for x-axis as usual. So this is XY line. I will call this one as a VP by HP, indicating first angle projection only. So what are the things visible in the front view? So observer is looking from this end. So for the observer, so don't you think this L-shaped panel is clearly visible? What is this L-shaped panel? This is 40 cross 60. So this is clearly visible. So followed by, don't you think this face of this inclined line is also visible in the front view? That's it. Only 2 things are visible in the front view. I repeat, this 40 by 60 and this inclined. So first duty is, what is the horizontal line? This should be 60 mm. So I will go for 6 centimeters in the normal scale. Once again, for the observer looking from the front, this would be the left side and this should be the right side. Let us analyze in that way. What is the height? Height is given as 40 mm. The first initial height is 40 mm. Let us draw 4 centimeters in the normal scale and give a thickness. What is this thickness? Where is the thickness mentioned? You can see the thickness is in par with this thickness. So this is 20 mm. So that means to say that 2 centimeters. What is this vertical height? Do not know what is the distance. We can analyze later stage if required. But this height, this thickness stands to be 20 mm. So from this, the other end, from the right side end, I will give a rise of 20 mm and I will draw a line here. For time being, I will draw a minimum thickness line, and from this line, I will draw the vertical line. So both will intersect at a point so that now I can darken. So now this L-shaped panel is visible. 60 by 40. Later I will give the dimension. Now I can see a further height. What is the height here? 20. And I can see the further width, that is once again, that is 20 mm. So it is clearly mentioned. So what is the height I am supposed to give now? I will give a rise of 2 centimeters in the normal scale, and I will go with the 20 mm extension, the width. Now this 20 mm is directly connected to the end of the right side. What is the right side end? This is the right side end. Let us not draw any vertical line over here. Why? Because this is made up of a single component. So now this completes the front view. Take a break and analyze for a while. Meanwhile, I will update the dimensions. This completes the front view. Now let us drop a perpendicular, let us drop the projection line to obtain the top view. Already as discussed in the previous case, what is that? Base of the front view should be equal to base of the top view. So what are all the things visible in the top view? So these platforms are visible, means to say that these 4 blocks are visible. So what are these blocks? Block 1, 2, 3 and this inclined block. But what is the overall dimension? Don't you think when you're looking from the top, this 60 mm is visible, this 60 mm is visible. Already 160 mm we have taken from the front view. I will take any convenient line as the reference line. So that will be 60 mm. Already we have taken from the front view. So I will take any convenient point. I will draw 60 mm, and the height of the top view I will measure it as 60 mm, 6 centimeters in my normal scale. Those who are using grid sheets, a few university will provide you with the grid sheets. For those students, you can make use of 6 grids, cover just 6 grids. So this is the 60 by 60. Now, what are all the things visible? So this platform is visible, followed by this block is visible, this square block is visible, this inclination is visible. Very important, inclination doesn't appear as an inclination in this case. Inclination is just a rectangle. So where is this block? This block is to a dimension of 20 mm. This 20 mm already it is drawn here. I will just draw one more perpendicular line here. Followed by, what is the next dimension of this one? So 20 mm. I will measure 20 mm and I will draw a line. So therefore, this completes the top view representation. Yes, if you're having a small confusion, let me give you a clarity over here. So this inclination is nothing but this portion. For time being, I will give it as inclination region. And this square block is, now you can visualize, this is that square block. And this small rectangular platform is what you can see over here. Followed by, this is a square block 20 cross 20. Hope it is clear. I will erase this inclination, what I have written over here. In the examination, you are not supposed to show like this. This is only for your understanding. Next, in order to obtain the side view, let me draw one profile plane. I will call this profile plane as x1 and y1. So from this intersection point, I will draw a 45-degree line. From the top view point, I will draw a line till it touches the 45-degree line. Yes, next from other end is well, let us draw one more line till it touches the 45-degree line. Go for one more projection line till it touches the 45-degree line. From this intersection point, let us draw a vertical line. Meanwhile, not to stop here, from the front view, I will draw one projection line towards the left hand side. From this end, I will draw one more projection line. Any extra projections we can remove later stage. So what is that already we have learnt here? The height of the top view. What is the height of the top view? This is the height of the top view. Now this should be equal to base in the side view. I will update the dimension here. So what is the conclusion? The height of the top view is equal to base of the side view. Yes, now this dimension goes like this and ends up by 60 mm. The height of the front view 40 mm. Height of the front view is equal to height of the side view. Yes, now this height is also equal to 40 mm. Now the observer is looking from this end. What are all the things visible? Don't you think? So this platform is clearly visible. So this rectangular block is visible. What is the dimension of this rectangular block? 60 cross 20 mm is clearly visible. Not to forget, this block is also visible. This appears to be front now. These two are in line now. Followed by this inclination. This inclined platform is also visible. Now let us see one by one. So this first thing is 60 by 20. So already 60 mm is there here. Followed by height 20. Now, this block appears to be front. What is the dimension of this block? This block is, height is 20. Already we have discussed. Why? Because 20 it is taken by this block. The remaining is 20. The overall is 40. Followed by the length is 40. So 40 by 20 block is visible. Already 40 we have left out here. Yes, not to forget the inclination should be visible. So what is the dimension of the inclination? This is 20 mm. So don't you think this 20 mm is left out here? So that goes from after this 20 mm to the complete height. Where is the 20 mm? So this is the top view, this is the inclination portion. Front view, this is the inclination portion. So this 20 mm runs all along the height. So let us give the complete height for the inclination. I will erase this what I have written over here. Now I will update the dimension. Yes, this is the front view, top view and the side view. So this completes the projections. Hope you enjoy this video. If yes, give this video a thumbs up. Please do share with your friends. Don't forget to subscribe. I will talk to you in the comments. Have a nice time. Bye.